And we'll probably have to pass the mics around, but that's what we'll let the panelists introduce themselves first. We'll start with Travis, and the question I have for you is just what does in your respective company, Inductive Automation, do to help your customers reduce unscheduled downtime, and then we'll let the other panelists talk as well.
Yeah, so my name is Travis Cox. I'm the co-director of sales engineering for Inductive Automation. We are a software vendor. We supply Ignition, which is a industrial applications platform to build HMI, SCADA, and MES solutions. So what we do is we provide a tool that can really connect to all the different kind of controllers and PLCs out there. We have support for a lot of built-in drivers, as well as supporting standards like OPC UA, so we can bring a lot of disparate systems together, bring that information into the system. We provide a licensing model that's unlimited tags, screens, and clients, and more. So allows us to scale that up and get access to more of that information. And then, of course, we have tools in Ignition for tracking OE and downtime in particular, to bring all the information in and to provide dashboards and drill down analysis for the operators.
Okay, and John?
Good morning, everyone. My name is John Fryer from Stratus Technologies. I'm a Senior Director of Industry Solutions. As you may have gathered from what Kyle said, to put it simply, Stratus builds the most reliable computers on the planet. Focus on many markets, but industrial automation is our fastest growing market. Why? Because when you want to collect data, when you want to make sure that your software is running for all your plants, you need that level of reliability that comes with it. You need that platform that isn't going to fail. And more than anything else, you need something that runs simply, that OT people who maybe don't have the right level of skills don't need to worry about the hardware that's supporting all those applications.
Okay, right. Justin.
Sure. Morning, everyone. My name is Justin Conroy. I work for Radix Engineering and Software. I'm the program manager for pulp and paper business in the United States. Radix Engineering and Software is an engineering service company. We do quite a lot, but just to summarize, we do traditional engineering, conceptual design, detail design, feed work, that sort of thing. Custom software development, and also automation and industrial IT. So everything from level 1 to level 5, ERP systems, MES systems, PIM systems, LIM systems, control loop automation, control loop tuning, APCs. And we also have a really strong team in data analytics and creating machine learning algorithms and many other types of systems.
Okay, Will?
Great. Good morning. My name is Will Trogdon. I'm the Vice President of Sales for Webelo. Webelo is a software company. We provide a software platform to develop applications for frontline workers. So the common theme with the speakers here earlier was all about the human activities associated with preventing downtime and increasing KPIs. And Webelo provides the ability to create applications that enables those frontline workers to achieve some of those goals. So thank you.
Okay, great. If the audience has any questions, and Camacho has the mic, you can raise your hand. If not, we have a couple of questions to get us started. One of them, and we might have to move the mic to the back row because I want to start with Kyle. And the question was, how do you support customers in remote areas, such as when you were talking about your trips to South America, when they have hardware or software problems? So, yeah.
So with all of our plants, we usually, as soon as we get the plant finished, we have a year service contract where any automation stuff that we need to help them with, we can. And we have a firewall set up usually, so I can dial in to their system and pull diagnostic data on any of their hardware or software to help track down the issue, and then talk with their people on maintenance on site to help track down the issue and replace any parts that need replaced.
Okay. And since it sounds as though that our other speakers also support a number of plants, so we'll start with Elliot and ask, how do you approach that? 'Cause I think you had told me you support like 15 plants, if my memory serves me right. We'll have this one doesn't reach. Actually, we got a remote right.
Okay.
Thank you.
That's better.
Yep.
So I run a support group. So my group does support 15 facilities. We support APC installations as well as regulatory controls through multiple facilities. We have a corporate DMZ as well as each mill has a separate DMZ. So for us, we usually use either a Next 9 type solution to enter the plants, or through the corporate side, we may just have a VNC type connectivity to get to the plants. But we do remote and on-site if we have to.
Okay. Let Dan.
So from, just hang on. So from our perspective, we've got 6 plants in 3 states.
Turn the mic, or switch on the mic.
Is that it? Just hang on. Hey, look at that. Okay.
Oh, well.
You did good.
Yeah.
So we've got 6 plants in 3 states. The majority of the plants are within 90 miles of one another. So outside of our Kansas plant, we can get somebody to support a plant pretty quickly. But for remote access, we're 100% virtualized. We've got micro-segmented networks. We do not allow direct access into anything outside of VM. So our engineers will go into a VM that has access to a specific VLAN. We don't allow direct access into the plants. And that's how we support it.
Okay. Do you have anything else, Craig?
Do you know what we're talking about, Craig?
Yes. I don't do virtual anything. So I drive a lot. I usually try to get to all the plants at least once a week. And I've reached out to the owners to try to get me performance system resources. And like I said, I'd latch on to whoever I can get my hands on, any abundant thinking person, whether it's a plant manager, ops manager, supervisor, a union employee on the floor. I'd reach out to everybody. Everybody has my phone number, so I'm on the phone a lot and I drive a lot.
Okay. And for our panelists, what solutions does your respective companies offer that really helps provide that your clients do remote support? So I'll start with Travis and we'll work our way down.
Yeah, so Ignition, it's a web server on a gateway, so we can access the Ignition application of the client remotely anywhere. So it could be through VPN, could be through a corporate WAN, put in DMZ, where data is shared between the production and the DMZ securely. With the licensing being unlimited, it's just a matter of going there and launching the client to get access to see that data.
Okay, John?
So from a Stratus perspective, our systems, as we said, are fault tolerant. They don't fail, but they're self-monitoring. And when they detect a failure, they will contact Stratus. And, we can have a discussion about how you contact Stratus, but let's just assume that they do with all the security these days. We know what's failed. We ship out a replacement part, generally overnight. Okay, if it's in South America in the middle of a cornfield in Brazil, it may take, a few days to get there. Everything is hot swappable. Don't need any IT expertise. Pop out the failed part, pop in the new one, or replace a box, plug everything back in, and the systems resynchronize themselves automatically. So the real beauty of this solution, certainly in the industrial space, is if you're in a plant, you're in a remote location, you don't have access to IT expertise. You don't necessarily even have easy access to skilled OT resources. You've got a smart operator there. You can keep everything running, get it back up to full fault tolerance, without taking anything down, without any planned or unplanned downtime from that perspective.
Okay, Justin?
So I mentioned earlier we're an engineering service company, so we don't have any specific products that enable this, but we've helped develop a couple. But really what we do in this area is, we've got a tremendous amount of industry expertise in all the verticals, oil and gas, chemicals, energy, metals and mining, pulp and paper, food and beverage. And so what we have supported customers with in terms of remote access is really around remote support. So if a customer doesn't have the ability to staff up their expertise centers, to actually support the different mills or plants that they're trying to support, we can help augment their teams to do that.
Okay, Will?
Yeah, so the Webelo VM appliance can reside in the cloud or behind the firewall on premise, but the platform has all the enterprise security implemented into the platform, and that allows for mobility access, whether that's dashboards, KPIs, and also the ability to take action on those alerts and notifications via mobile devices. So pretty much anywhere in the world where you might have that network connectivity.
Okay, great. If we have any audience questions, certainly go ahead.
Morning, Craig. Rick Morse from Rexnord. Question for the end users. You spoke very well about the IT and the operations folks and coordination. Guys from Sugar Creek touched on an interesting point of the repeatable Paretoing bucketing of the reason codes. There's a third group here that often gets kind of short shrift, and I'm wondering where in each of your organizations the maintenance crew is and where the standardization of the reason codes for the things that they find after the machine is down gets folded back into your operations reasons codes.
I can take that. Well, you want to start?
I purposely left things off of the dashboard. The dashboards are really intensive. For us, though, we actually have a second system that we use to collect all of our downtime data that we call an AAL database. We actually, even though we update the AAL database with those type reason codes, we then still pull or can pull the data from the AAL database, populate that dashboard, as well as populate other systems.
Yeah, so from our perspective, we've had a CMMS system in place for, 20 years, but the recent iteration of that's about 13 years old. And when we started pulling data from the machines with common downtime codes, you got to match it up with common maintenance codes, right? So in our CMMS system, which actually all the reporting from our CMMS comes through Ignition because Ignition's got a better reporting module than our CMMS does. We have common, we've got work order codes, right? So it's preventative, it's, an emergency breakdown, whatever. Then we've got failure codes, we've got equipment types. So we can Pareto out where failures from a maintenance perspective happen outside of the downtime. So we know where we're spending our money and our hours, even if the machine's not down. So we've got machines that run great, but we spend a lot of money per hour to run them in labor, in parts. And a lot of that is people don't pay attention to. They pay attention to the downtime. They don't pay attention to the cost of ownership of a machine. So we make decisions based on our downtime and our cost of ownership on when you have to revamp a machine, when you have to replace a machine. Does that answer your question?
Anyone else from the supplier side have any comments to the question? Okay. Next, any audience? Go ahead.
I'd like to, Elliot, so what you're trying to do is you're trying to avoid and reduce downtime. And when you get into a situation where downtime is coming if you don't do something about it, how important is it to have tools in front of you, the fluidity of those tools, to be able to navigate quickly? Because if you look back 10, 20 years ago, to get the data that you're looking for can be minutes, 5 minutes, 10 minutes to get to the problem. How important is the fluidity of the environment? Because you're going to be switching from one tool to the next to get to the answer.
Huge. And actually, I would tell you, because of the pattern that you just described, what we're actually going to is analytics with pattern recognition so that we remove those needs. So for the dashboards, and let me be for all clarity, Justin, his company Radix, built the dashboards that you saw. As I said, for GP, we're doing dashboarding. Within those dashboards, there's analytics built But even outside of those dashboards, we have other analytical processes that are working on pattern recognition and actually predictive pattern recognition so that we alert, and we're trying to be able to predict out more than 5 minutes, more than an hour. We're really trying to predict out considerably forward before, so that in most cases, we either avoid a process issue that we see coming, or we can avoid or at least notice a reliability issue that's coming and then plan for that reliability issue days out.
So I guess one of the things that Ignition's got that's pretty cool is they've got an alarming module, and an alarming scares people when you say an alarm, right? That means something bad's happening. We use alarming as a notification module, right? So we get email notifications, text notifications, voice notifications, and it's not just based on when something's bad. We look at rate of change. So if something is approaching bad, we'll notify people before it's actually bad so they can respond.
Okay, anybody else? Anything from the supplier perspective? Okay, next audience. Oh, hell, here comes Alan.
Yes, question is for Kyle. You talked about a lot of redundancy in your South Africa plant. You talked about having a ring topology. You talked about the HMI having some redundancy. You talked about your I/O servers, and it sounded like you had mentioned that the I/O servers that you were talking about were being switched manually. So I was curious about redundancy. Sounds great in theory, and in reality in oil and gas, it ends up causing more downtime than if we hadn't put it in. So I'm just curious if you can speak towards how your redundancy is working, and you see it being something that's sustainable.
So for the tag servers and things like and the data servers, depending on the system, one of the systems I usually use, it does automatically switch. So you don't get very much you don't have very much freezing or anything between switchover. To kind of answer your question, we see redundancy as a very big, important thing, and high availability structures and fault tolerant structures in order to try to reduce any downtime and loss of control of the plant and things like that. Now, keep in mind that the plants that I work on are small compared to a big oil and gas company or something. So the redundancy that I use is all in one area versus with an oil and gas, or like he said, at Georgia Pacific, right, where they have multiple control rooms that are basically multiple sections of a plant. All of my control happens in one area. So having that one area redundant as much as possible, you can keep control of your plant.
Okay.
I hope that answers.
Follow-up?
So I spent many hours fighting redundancy. The three things that I would simply say is this: poor design, redundancy becomes a huge headache. Aging redundancy, because the initial redundancy was usually built for a certain load. So if the loading has increased beyond what is really there, the network starts to fail, and the swap over that is based or intended to happen gets trapped in the loading, and it then crashes. But lastly, when done really, really well, when really thought out, it definitely can save you, but you have to review and update. Something that was built 20 years ago for a certain loading isn't going to be sustainable if you increase the load on the system.
Oh, you're all set? Okay. Any other audience questions? Oh.
So we often find that we'll have a downtime event, and we'll capture the data, we need to go after the mechanical or electrical failure. But what also happens is that downtime event is exacerbated by the reaction of the operators and maintenance. And so we tried to like capture all that in this SOPs, but then we end up with a book about that big of SOPs that nobody could ever read. How do you guys capture that knowledge and make it accessible, or do you do any of that?
You want that one?
So one of the things that was pointed out during the presentation was minimizing operator intervention. This is exactly why we are working to minimize operator intervention. Personally, I describe a lot of those as sympathy trips. I lose one thing and then 3 or 4 other things trip out in sympathy of the first thing that went down. So what you really are trying to do or have to try to do is to automate the responses. And then you have to train the operators on the automated responses, because what happens is the operator sees something happen. It didn't turn it back on. The operators see something happen and they want to respond, and quite often their response is either late or too aggressive. So if you can automate the response, that's great, and that's what we generally do. But the second part is you have to train the operator to be integrated with that system of automated responses.
So when you talk about SOPs, in our world, you've got SOPs for common maintenance tasks, right? Everybody knows about those. From downtime perspective, there are 3 critical things we look at. So if you have a major event that causes major downtime, you want to create an SOP on how to fix that, even if it'll never happen again. If it's something that was extremely painful, you have to get it. Safety, environmental, single events, recurrent events, doesn't matter, you need an SOP. The one that is missed the most are the recurring little events. So when you see that you've got these little micro stops, or you've got a packaging machine that's running 1 package per minute slower than it's supposed to, you need an SOP on how to analyze, why. Is there a vacuum prop? What do you check to see why the machine's running slow? The beauty of the system that we've got is we code downtime into predetermined buckets. So anything that's outside of those buckets, we've got basically an other with a comment. We analyze those every week to see if there's another bucket we need to add. Something that wasn't a problem last year might become a problem, this week. So we'll add another code. And for every code, we should have a response that's pretty programmed. You can't cover everything, obviously, but at least get people looking at the right direction on what could have caused the problem and what could they do about it.
Okay.
That's your favorite.
Yeah, so in my world, I'm attending all these meetings, I'm driving the meetings, and I'm preaching the word of data collection every day. So I try to get people to understand how to analyze the data, not only for mechanical failures, but if it's an operational failure, if it's a sanitation failure, if it's some kind of other failure. And I don't want to create 1,000 SOPs. I don't go out and say, build me an SOP for every piece of equipment on the floor in every situation. So we like to look at the critical situations. Hey, if this happened 4 times in the last 2 weeks, this should probably be an indicator for you. Now go build some kind of training or analyze the training you do have. So we do that on the operations and sanitation side, not only mechanical.
Okay. Anybody? Yep.
I just want to roll back to the previous question about redundancy, because it's a very important one. Software redundancy, and I happen to have worked in this area for about the last 20 years, both software and hardware redundancy. Software redundancy is notoriously hard to implement. There are so many corner cases, you don't exactly know when anything's going to fail over. So the beauty, frankly, of the Strata solution is you don't need to implement software redundancy. It's all taken care of the redundancy at the hardware level. And that's what makes our solution so simple. So if you have an old system, 20 years old, and you realize that you need a redundant implementation around it, but you want to keep that around, Strata solution will do that for you. It won't fail. In fact, the first time a lot of our customers realize they've had a problem from a hardware perspective is when we call them, not them calling us. So again, if redundancy, availability is important to you, don't think that going just down a software route, where you need multiple licenses, and there's a whole cost aspect to this that we can help with as well, just because of the way the Stratus solution works. So I know that's a bit of a plug for Stratus, but there are ways to do it. It's why a lot of people end up coming to us, and it's why companies like ICM use our solution.
Okay, any comment?
Yeah. Well, just to go back to the question about SOPs. So, we saw a project a couple of years ago. It was really interesting. And it was really trying to solve not only the problem of, complex SOPs that, as you say, were this tall, but also, the aging workforce, knowledge walking out the door constantly. So it was for ONS. It's Brazil's power transmission company. And so what we helped them with, at least to sort of reduce some of that, was we actually built their startup procedures for the entire grid into the PI system. So the startup procedures are very, step-based, if this, then this, if this, then that. And so in a visual manner, we were able to say, okay, well, if this segment of the grid is already running, this is the next thing you need to do, this right here. Okay, now that that's up, now you need to go over here and get this transformer up and running. Okay, now you need to do this, and now you need to do that. And so it reduced tremendously, the amount of paperwork that they had to read, and the training, all the information that's in the graybeards, if you will, their heads on how to actually start the system up is now embedded in the PI system, and so anybody can kind of just follow the directions.
Okay, any comments? Okay, any final questions from the audience? Okay, then we'll wrap up with, if you had to give in one sentence or a few words, if you had to advise your customers, or as you're making a presentation within your plant, on what's the one thing you would advise people do first to help reduce unscheduled downtime, what would you do? Limiting yourself to one sentence or one bullet. We'll start with the speakers and then go to the panelists as far as how you'd advise your customers.
The mic's up there.
Yeah.
Well, I know what he's going to say, so I want to steal his thunder.
Oh, okay.
If there's one thing I would tell you is get accurate data, period. If you want to make a change, you have to be able to trust your data. And if you can't trust your data, then you're just going to run around in circles.
Yeah, so I'm going to steal Craig's, listen to the operator. So once the data points you in a direction, engage everybody in that area to determine what the problem is and be able to be involved in the solution.
Okay.
The one thing I will say is take a look at your designs and your network and things like that, and make sure that you can handle single points of failure and things like that throughout the network and the plant before you start working too hard on other things.
You want to add to Dan?
Yeah, I'd agree with Elliot and Dan. So once you have to get accurate data, and of course I'm going to say it's important to get operators, supervisors, the person down on the floor involved, and show that data to them in a way that's going to be engage them and let them know how what they do is important.
Okay. Good, Travis.
Yeah, so certainly I'd echo the getting accurate data. I mean, if you're relying on operators to manually enter that downtime data, it's certainly much better at least to get some automatic signals from the PLC to know that it stopped. Then later they can go back and assign better reasons, but at least you have the right time that was associated with it. And the other thing that I'd say, I know is just one sentence, but is to really get operators on board with the objectives of what we're trying to do. It's not like you're a big brother trying to watch into the operations and trying to get them in trouble for if it's not as efficient, but to make sure they're a critical part of the overall strategy to do better.
Okay.
So I think, the thing to remember is as data becomes more important, to developing these KPIs, and, you hear this from the speakers today, make sure that you've got an infrastructure that isn't going to lose the data. Because if you don't have it in the first place, you can't do any analytics on it. So just make sure that you're going to be able to capture it and not lose it along the way, because gaps can really throw things off.
Justin.
I would suggest just go for some quick wins. I've seen too many situations where customers have really good results on pilot projects, and then they put the whole thing on hold because it's not perfect yet. You know? But we saw great results, but it's not perfect yet. Let's put it on hold for a year. Just go for it. It's not going to hurt.
And I would say from a Webelo perspective, it's about enabling frontline workers and leveraging mobile devices and putting an interface on a mobile device and really taking advantage of the human knowledge at the frontline worker and them dealing with downtime and reducing that. So.
Okay, great. Please join me in giving our speakers and panelists a round of applause. Did a great job. And 10 o'clock break. We'll see you back at 10:30. Thank you very much for attending.
Apologize, that was